All right, guys, so you caught me on Amazon. All right, so here's the deal. I like avocado oil. I bought a bottle of it from BJ's and I don't remember the price, but I hadn't been able to get to BJ's, so I went online and I was like, dude, let me go ahead and see if I can get it on Amazon. And boom, I see there's a two pack. It's 500 milliliters. Each bottle, I'm assuming, and it only is going to cost me $23.95. That's pretty good. And so I'm starting to calculate the price and I want to figure out, okay, does it make sense for me to buy this two pack? So what I do is I calculated that the 500 milliliters per bottle would be 1,000 milliliters, 500 plus 500, not a big deal. And then I found this conversion factor. I don't hold on to it in my head, but it's about 30 milliliters per ounce. So after I figured out how many ounces I was getting, it's about 33.3. Then I figured out how much it cost me per ounce. Just stay with me. So it cost me 72 cents per ounce. So I was like, I guess that's not bad. I don't remember how much I paid at BJ's, but that seems pretty good. So then I scrolled down and I saw, what did I see? Same exact brand. Here is this bottle. Let me see. This bottle is 33.8 ounces and it's at a price of $18.49 plus this little shipping and handling, if I'll be real. But I didn't consider shipping and handling the other one. So let me just go straight for the price. So as I'm looking, I'm realizing that the price here is going to be per ounce. I'm going to divide 33.8 and going to divide 18.49 by 33.8. What I'm going to figure out, or what I figured out, is the price per ounce is 54 cents or 55 cents. So this is the better price. But what I noticed is that Chosen Foods, that's the company that's selling it, is not being consistent, meaning their pricing isn't proportional. They're not keeping the same rate per ounce. And so that's what we're going to talk about today. We're going to talk about proportion versus non-proportional relationships. So we are in chapter 6. Still, we're looking at proportional and non-proportional relationships. And here is our vocabulary. So proportional means that quantities with constant ratios or constant ratio ratios. So let's say for every hour or for every 5 hours somebody works. Let's start there. For every 5 hours somebody works, they get paid $10, right? Or let's say $100. That's much better. So you get paid $100 for every 5 hours you work, and then if you were to work 10 hours, how much do you expect to get paid? Well, hopefully 200, right? Because that would be proportional. That, as this doubles, the same rate of increase happens for the top and the bottom of your proportion. Non-proportional is a little bit different. I started doodling some stuff here. Let me take it off so we can go back. Non-proportional is if you have a situation where, let's say, you get paid your $100 for 5 hours of work, and then you get paid, I don't know, $150 for 12 hours of work. It's not just that it's unfair, but it's not consistent in terms of the rate. If we go back here and we look at the rate, what is the rate? What is the unit rate here? Well, the unit rate, we know we divide the top and bottom by 5. When I divide the top by 5, I get $20 per hour, right? You get 20 per one. Well, what happens here when I divide 10 in the denominator and the numerator? I get $20 per hour. So that is consistent. Over here, we still have the $20 per hour, but what happens over here? We're not getting the $20 per hour. When we divide 150 by 12, we're going to get something a little bit less. So that's what we call non-proportional. When you have a constant rate of proportionality, that value, that relationship looks like this. Y is equal to K times X. So let's think about it in terms of what we had here. Here, I could say, basically, since I figured out that the hourly rate is $20 per hour, I could honestly say that your pay, Y, is equal to $20 times X, where Y is your pay and X would be your hours, correct? And in this case, 20 is the K value, or your constant of proportionality. It's the thing that keeps everything consistent. It's basically the unit rate once you break down that relationship. So proportional quantities, when things are proportional; non-proportional, when they're not, when you don't get the same unit rate; and constant of proportionality is the unit rate when you have a proportional relationship. Let's take a look at a couple examples. Example 1, we're going to identify whether this relationship is a proportional relationship. So we've got coffee by the pound and the cost per dollar. So determine whether the coffee is whether the cost of the coffee is proportional to the number of pounds. Explain your reasoning. So if I did 1/3, or I could honestly do cost per pound. So I'm going to actually change my fraction. I will write it as 3/1. It just feels comfortable. Not that 1/3 was wrong. If I say $3 for every 1 pound, that's that unit rate. What if I spent $6 on 2 pounds? What's the unit rate here? Well, clearly that's 3-to-1 as well. So this is seemingly pretty consistent. If I spent $9 and got 3 pounds, is that consistent with our unit rate? Divide top and bottom by 3, I get 3-to-1. And same thing here, 12/4. When I divide top and bottom by 4, right now my division here, I get 3-to-1. So from here, I see that the unit rates of each of these is the same. Therefore, indeed, this is a proportional relationship. And that's my explanation. Let's look at example 2. Example 2 says identify, again, proportional relationship. So we're going to check to see whether the number of miles is proportional to the number of hours. So in 1 hour, I was able to travel 50 miles, 2 hours, 70 miles, 3 hours, 90, 4 hours, 110. So I'm going to write it a little bit differently. 50 miles for 1 hour. So that's this relationship here. I think you guys probably already see that this isn't proportional. 70 miles for 2 hours. Well, let me break this down into the unit rate. I would divide the top and bottom by 2. I get 35 miles for 1 hour. So this rate here and this rate here is not the same, and therefore I already know it's not proportional. I don't have to go on and check the other ones, but I will. So 90/3, if I did the unit rate, divide top and bottom by 3, this is 30 miles per hour. And then finally 110 divided by 4. If I divide top and bottom by 4, I'm going to get 27.5, I think. 27.5. If I'm wrong, you guys will tell me. 27.5 miles per hour. Clearly, all of these are all kinds of not proportional. Nothing's proportional. If 2 weren't proportional, we'd be done, but I just checked them all just so we can talk about it. All right. Example 3. So not proportional. That was example 2. So example 3. We're going to look at describe the proportional relationship, and we're gonna kind of think about using this proportional relationship to answer a question. So here in example 3, it says describe the proportional relationship. A circle's circumference is proportional to the diameter, and I'm going to write that down. So the circumference over the diameter, this is a proportional relationship with any circle, and you guys know about this from Pi Day. However, let's talk about it here in our class. So a circle's circumference is proportional to the diameter. A certain circle has a diameter of 4 and a circumference of 12.56, and this is meters. 4 meters over 12.56 meters. And then they're asking us, what is the circumference of a circle with a 6-inch diameter? Yeah, with a 6-inch diameter, we're looking for the circumference. And I guess the answer is going to be in inches. So here's our situation. Circumference, this is all consistent. We expect all of this to be a consistent proportional relationship. So what we need to do is kind of figure out what's going on. So what we know is, in addition to this relationship being as it is here, right? We also know that from earlier on when we talked about the constant of proportionality, the fact is C times some K value is going to give K times D is going to give me C. We should know already that circumference is equal to pi D. And what we're going to do is we're going to see that pi being 3.14, approximately 3.14. What we're going to see is that actually occurs when we do our division here. When I figure out what the unit rate is, what the unit for each unit in the diameter, I'm going to tell you what the circumference is. The relationship is 3.14 over 1, right? So this is my constant of proportionality. Do you remember us talking about that earlier? So what I would do is, to figure this out, I'd take the circumference here for this next problem, and I'm going to multiply by 3.14 times 6 inches. When I do that, I get about, the circumference is equal to, I'm using my approximation values, about 18, and I don't know, 18 point, I don't know, what do I have here on my calculator, 18.84 inches, something like that. All right, so here is one way that we can use that constant of proportionality. Remember, we find the unit rate when we have a relationship that's proportional, and we know all relationships in that proportional situation can be described in this way. Let's see if we have an assignment for my good friends. Our assignment is not too bad. We're dealing with pages 283 and 284, and you have a few problems to work on there. Have an excellent day. I look forward to seeing you guys.